Quantum supremacy. It sounds like something straight out of science fiction, right? It promises this whole new era of computers, machines that can do the impossible. But what on earth does it actually mean? Well, that's what we're going to figure out. Let's dig in and separate what's real from what's just hype. So let's just jump right into the big question here. Picture this, a brand new type of computer solves a problem in the time it takes you to make a cup of coffee. But for our best, most powerful supercomputer, that same problem would take, well, billions of years. So is this a real revolution, or is it just a clever parlor trick? That question is at the very heart of this whole debate. All right, to get to the bottom of this, we've got to start with the promise itself. What is this incredible claim that has everyone so excited? Okay, so at its core, quantum supremacy is really about one thing, hitting a specific scientific milestone. It's that moment, that single point in time, when a quantum computer proves it can do something that is just flat out impossible for any normal or classical computer. You can think of it like the very first time a bird actually flies. It's proven it can do something that, all its cousins on the ground just can't. So the big question is, how? How do they pull this off? To really get what all the fuss is about, both the good and the bad, we need to pop the hood and see what makes these things tick. You know how all our current computers, our phones, everything, it all comes down to bits, right? Simple on or off switches, a 1 or a 0. That's it. Well, quantum computers use something totally different called a qubit. And here's where it gets wild. A qubit isn't stuck being a 1 or a 0. Thanks to some very weird physics, it can be a 1, a 0, or kind of both, all at the same time. This whole idea has a name. It's called superposition. And honestly, the best way to think about it is like a spinning coin. While it's in the air, spinning. Is it heads? Is it tails? Well, in a quantum sense, it's both at once. A qubit is just like that spinning coin, holding all these possibilities simultaneously. And that just blows the doors wide open for computing power. So you might be thinking, okay, why can't we just build a really powerful supercomputer to pretend to be a quantum computer? And this Reddit user, Sketchy David, absolutely nails why that doesn't work. It's all about how it scales. See, faking 1 or 2 qubits, not too hard. But every time you add another qubit, the difficulty doesn't just get a little bigger, it explodes exponentially. You hit a computational wall, and you hit it fast. And this is what sets up this incredible race we're seeing. It's a total showdown. On one side, you have the people building these new quantum machines. And on the other, you have software geniuses trying to find clever ways for our old school computers to keep up. Yeah, and this is not a race with a clear finish line. It's more like a tug of war. Back in 2019, Google's Sycamore team said, "We did it. Supremacy is here." But then almost immediately, other researchers figured out smarter ways to simulate it, kind of pulling that claim back. The goalposts are always moving. The quantum hardware gets better, then the classical software gets smarter, back and forth. So that brings us to the very latest chapter in this story. Get ready for this number. Researchers with a brand new processor calculated that for our fastest supercomputer in the world, a machine called Frontier, to do one specific task, it would take almost 6 billion years. And this is the machine that did it, the Zuchongzhi 3.0. How long did it take this processor to do that same nearly 6 billion year calculation? A few hundred seconds. I mean, just let that sink in. That is the kind of mind-bending leap we're talking about when we talk about quantum supremacy. So, case closed, right? Quantum computers win. Well, not so fast. It turns out there's a huge debate about what this achievement actually means. Let's get into the other side of the story. Okay, so first up, there's a serious scientific argument against all this. A researcher named Gil Kalai has this theory. He basically says that these quantum computers are super sensitive. Any little disturbance, what scientists call noise, can throw them off. And his point is, this noise might make the answers they spit out totally random and unpredictable. So are they even solving the problem correctly? It's a huge question. And then there's the argument you hear a lot. And frankly, it makes a lot of sense. This commenter just puts it perfectly. If you have to cook up some weird, custom-made problem just to prove your computer is supreme, does it even count? Why not have it do something, useful? And that's the thing. The problem they're solving is called random circuit sampling. And it's basically a math puzzle that was designed for one reason and one reason only, to be really, really hard for a regular computer, but pretty easy for a quantum one. So the big critique is it's like you built the fastest car in the world, but it can only win on one very specific, very strange racetrack. It doesn't actually do anything useful in the real world. So this whole debate really forces us to ask a better question. If supremacy on a weird, useless problem isn't the whole story, then what is? What should we really be paying attention to? Well, to answer that, we need to get a few key definitions straight. Okay, so first, let's nail down quantum supremacy one more time. Think of it as a pure science experiment. The goal is just to prove that a quantum computer can do something, literally anything, that a classical computer can't. The task doesn't have to be useful at all. It's just about proving it's possible. Now this next one, quantum advantage, this is a whole different ballgame. This is when a quantum computer solves a problem that actually matters in the real world. Something practical, something useful. This is the moment that technology goes from being a cool science project to something that could actually change things. And there's one more step, quantum utility. This is maybe the most down-to-earth one. It's the point where these machines are just helpful. They're providing useful answers for businesses, even if we can't mathematically prove they're faster than every possible classical algorithm. This is when quantum computing starts to pay the bills, so to speak. So when you lay it all out, the difference is pretty stark, right? Supremacy is a science milestone where the task can be totally abstract. Advantage, on the other hand, is a tech breakthrough where the task has to be practical and useful. It really all boils down to a shift from asking, can this thing even work, to asking, okay, what can this thing do for us? So what kind of useful problems are we even talking about here? Well, this is the exciting part. We're talking about things that could genuinely affect your life. Imagine no more traffic jams because a quantum computer is optimizing the flow of the entire city in real time. Or discovering new medicines by designing the perfect molecule from scratch. Or even creating new materials to build batteries that last for weeks. That's the real promise here. So where are we on that journey right now? Well, experts say we're in the NISQ era. It stands for Noisy Intermediate Scale Quantum. But what it really means is the machines we have today are pretty cool, but they're still a bit small, and they make a lot of errors. They're noisy. They're not quite ready to tackle those massive, world-changing problems just yet. We're still in the very early innings. So it's pretty clear the whole conversation is changing. The real race, the one that matters, isn't about bragging rights over some obscure math problem. It's about getting to that quantum advantage and utility, making these incredible machines solve real problems that affect every single one of us. Which kind of leaves you wondering, doesn't it? If you could get your hands on one of these things, what's the first problem you'd want it to solve?